All right, good morning, guys. Thank you so much for watching. So today I'm going to go over factoring, and this is going to be kind of a basic introduction. And we've really been doing all these lessons leading up to this point, and they're all really focused around this idea, and they come and they kind of culminate in this idea of factoring that we're going to go over now. So this is a review from like fifth grade math, I guess. But what are factors? So factors are basically numbers that can multiply to fit into like a bigger number. So for example, let's say I have the number 12. You may remember this from fifth grade or around then when you did factor trees. So factor trees were when you like look at a number and you'd break that number up into like all the things that you could multiply into that number to figure out what fits into that. So what multiplies into 12? Let's just do a little bit of a review on factors. So 12 could be broken down into 3 times 4, right? Because 3 times 4 multiplies to 12. So 3 and 4. And then can I break down 3 and 4 further? So 3 I can't break down any further, but 4 I can multiply 2 times 2 to get 4, right? So the factors of 12 are 3, 2, and 2, or really 3 and 2, I guess. So the point I'm trying to teach you here is that basically when we factor something, that means we're just breaking up a big thing and breaking it into the smaller parts that we can multiply to get that. So now we've done things with polynomials. A lot of in my past few videos, I've gone over how to do polynomials. I've done some basics on polynomials. So what I'm going to do now is I'm going to show you guys how to look at these polynomials and how to determine how to break up these big polynomials into the smaller segments and the smaller chunks. And this will be very helpful for the rest of your math career. So let's do an example. When I say I'm going to factor quadratics right here, that just means anything with the highest power being 2. So if, for example, if I have something like x squared plus 8x plus 15, the highest power or the highest degree or highest exponent, whichever one fits best into your brain, the highest exponent is 2, right? So because we know that, that tells us it's a quadratic. Now, you don't need to really know that much about quadratics right now. I'm going to go over that in my next video, most likely. But just it's good to know that this is a quadratic. Anyway, so we want to break down this polynomial right here, x squared plus 8x plus 15. So it may look a bit daunting, but let's just see what can we do. So the first thing we can do to figure out how to break something down is we look at this thing and we have to say, okay, I need to find the product of the first term, the coefficient in front of the first term, and the constant of the third term. So the product of these two things, right? That's our product. And the two numbers that we're using to get that product have to also add up to get this this number right here as our sum. So I know that sounds really weird. You probably don't understand that, but it's going to make sense in a second. So let me give you an example, or let me speak more generally, I guess. So when we have a quadratic, it's usually written in the form ax squared plus bx plus c. And when we're given this in this format, we have to essentially find two numbers that can I misspelled that. We have to find two numbers whose product is the same as this letter a right here and this letter c right here. And they also have to add up at the same time to be the same as the number and this little part where it's called b. So the product would be AC and the sum would be b. Make sure you like know this rule in particular, and it may not make sense right now, but like screenshot it or something, because this rule is really important for understanding how to do all the practice problems moving forward on this particular problem. So let's go back to this example I was showing you now. So we have x squared plus 8x plus 15. So what we're going to try to do, we're going to try to use this rule right now. So we're going to try to find the product of the coefficient of this and the constant, which is this. So there's really a number in front of this x squared if you think about it, right? Because it's 1 being multiplied by x squared, which is the same as x squared, but there's technically a 1 right here. So we're going to look at that 1, and we're going to be taking that 1 and multiplying it by the 15. Okay? Just make sure you get that. 1 times 15 is our product. So I'm going to write that down. The product is 1 times 15, and that is equal to 15, right? That's not too bad. And now the sum has to also add up to this middle thing right here, right? So this number right here, the number 8. So now we have to ask ourselves, what are two numbers that multiply to the number 15 and add up to the number 8? All right, think about that. Think in your mind. And here's the thing, right? This may not come naturally to you at first. It didn't come naturally to me when I was first learning this, but with a lot of practice, you'll be able to quickly think of two numbers that multiply to the product and also add up to the sum at the same time. So you may, let's see if you got the answer. So if we're thinking about what two numbers multiply to 15 and add to 8, the answer is very simple. It would be 5 and 3, because I can multiply 5 times 3 to get 15. And I could also add up the numbers 5 plus 3 to get me 8. So now that we know those are the two numbers, what we're going to do from now is we're actually going to take those two numbers and we're going to put them into a new format. So we're just going to say that it's going to be x plus 5 and x plus 3. Because we found the two numbers that multiply out to get us the 1 times the 15, right? From here to here. Those two things multiply out to 15. And these two numbers, 5 and 3, also add up to the number 8. So I hope that makes sense. So how does this how does this work out? So basically, if I were to FOIL this out, right? Because I've taught you guys how to FOIL now. Basically what's going to happen if we tried to FOIL this thing we just got, it's going to give us the same exact thing as our original function that we were given. Because if I FOILed this out, it would be the first, which is x squared, plus the outer, which is 3x, plus the inner, which is 5x, plus the last, which is 15x. Oh, no, sorry, just 15. And then that would add up to x squared plus 8x plus 15, right? So therefore that shows us that this is the same thing as this, right? We're just breaking it down. We're just breaking this thing into the smaller chunks, which are factors, just like we did over here. It's no different. So now I'm going to do another example for you guys. I'm going to erase this part so I can have some room to write. Let me actually bring this down as well. Okay, so let's do another example, and we're going to try to do a very similar one so you can kind of see a pattern here. Let's say I gave you x squared plus 5x plus 6, right? So this is a new problem. X squared plus 5x plus 6. How would we do this? So the same exact thing as we did before. We want to look at the product of a times c, and it has to add up to b. So if you got what a, b, and c are, it's right here. A, b, and c. Okay. So let's see. We already know that there's like an imaginary 1 that's right in front of the x squared, right? So we know that a is equal to 1, b is equal to 5, and c is equal to 6. Okay, so from there, we're going to do our product. We're going to find the product, right? So a times c would be 1 times 6. So 1 times 6. I'm not realizing I actually put the wrong colors in the diagram here, but so I'm just going to change that for you guys real quick so it doesn't confuse you. A, C, and I think this was orange. I want to be consistent with this so you guys don't get confused with this. Okay, so as I was saying, we're going to do 1 times 6, which is our product, right? So our product would be 6. So product is 6. And our sum would be 5, right? Because that is what our B is. Okay. So now we have to ask ourselves again, what two numbers could I multiply to get the number 6? And what two numbers could can I use those same exact numbers to add up to the number 5, right? So let's think, what can I multiply to get 6? How about 2 and 3, right? 2 and 3 would work because it multiplies out to 6. So that would work. And then 2 and 3 could also add up to 5. So that would work too. So therefore we know that if we're doing I don't, okay, so we're doing 2 times 3, and we're doing 2 plus 3. Those would work, right? So now from here, we're just going to write this as x plus 2 and x plus 3, right? Because that should work out as well. And then again, we could if we FOIL this out again, which I'm not going to do because I just showed you how to do it. But if you were to FOIL this out, it would also equal to x squared plus 5x plus 6. And that is the same exact thing as this original function that we were given. So it works out perfectly. So the answer would be this, and the answer to the last one was also this. Okay. So now I'm going to give you guys one more, and this one's a little bit more challenging, and then I'll teach you another factoring method for a different type of scenario in which you're given a problem. So let's look at this one. Let's say I gave you 3x squared minus 8x plus 4. So think about this too. How could I do this, right? How can I figure this out? Because now we're given, it's not 1 in front of the x squared, right? It's a new number. So how can I do this? It's the same thing, right? Because we just multiply 3 times 4, because this is our a and this is our c. And if we looked at our rules again, we're multiplying a times c, right? So we're just going to multiply 3 times 4 because it's a times c. So the product is going to be of 3 times 4. So the product would have to equal to 12. And then our sum has to be for the letter b, right? Because b is the middle thing with just in front of the x. And so our sum would therefore have to be -8, not +8, but -8. Okay, you have to make sure you're including that little negative right there. So the sum has to equal -8. So this one's a little bit more challenging, but I'm going to show you guys how to break this one down as well. So to do this, now we have to think, okay, so what two things could I multiply to get the number 12? And if I took those same numbers, could I also add them up to get the number -8? Okay, so let's think. How about, let's see, what could we do? We could do anything really. How about -6 and -2, right? Because I could multiply -6 times -2 to get +12, and I could also add up -6 and -2 to get a sum of -8. So that would work perfectly, right? So again, these numbers don't come naturally to your minds a lot of times when you're now starting this, but you have to do a lot of practice with this to actually start to figure it out and really have it come to your mind very quickly like it just did with me. So again, the product would be, let me actually get rid of that. Okay, so the product would be -6 times -2, which works out, sorry, -2, which works out, and then -6 minus 2, which also works out. So from there, how do we do it? Because it's a bit different now because we have, oh, sorry about that. We have the number 3 in front of the x squared. So we can't just write it into this form we did right here, right? Where I can just plug in x plus 2, x plus 3. It's more challenging now because we have this number in front of the x squared, which changes everything. So for this one, we're going to do this new step. So what we're going to do is I'm going to show you how this actually works out. So we're essentially taking the -8, right? And we're splitting that up into -6x and -2x, right? Because if you think about it, that's what we're really doing, right? We're trying to take the -6x and add that to -2x to get to the -8, right? That's what we were doing all along. So now we're going to write that like that, the way I just did. So now we want to actually split this whole thing into 2 parts, right? So we're going to write this out as 3x squared minus 6x minus 2x plus 4. So all I did from there was, instead of just having the -8, right, I just broke it up into the -6 and -2, which we had figured out from this whole step right here. So now that I've figured this out, we're going to do this thing called factoring by grouping, which actually is going to tie into our next part of the lesson, as you can see right here. So this is like our first example, and then we'll do another example with just factoring by grouping. So we're going to factor by grouping for this. When we say factoring by grouping, all of that means is we're going to take this giant thing and we're going to split up into two halves, because this expression that we're given has four terms used, right? We have 3x squared, negative 6x, negative 2x, and 4. So we're going to split this up into two equal halves, right? So when I say I'm going to split it up, all I mean is we're going to put a parenthesis around the first two terms like this, and we're going to put another parenthesis around the second two terms like this, right? And now from here, what we're going to do is we're actually going to we're going to factor out some number from each of these parentheses, and we're going to figure out how to do this. And actually, there should be a plus sign, I believe, right in front of this, so it can be a bit more clear. Okay. So what we're going to do now is we're going to look at this expression first, right? What is a factor between the 3x squared and the negative 6x? Let's think. Okay, so I could multiply 3x into this, and I can multiply 3x into this, right? So that is the greatest common factor between both of those. Because it makes sense, right? If I divide 3x into 3, if I divided 3x into the 3x squared, right, that would just equal to x. So that's all we would have left. And if I were to divide 3x into negative 6x, that would equal to negative 2. And there really is nothing in common between these remaining things we get, right? So 3x would have to be the greatest common factor. So now that we know that, we're essentially going to go right here, and we're going to write 3x on the outside of the parentheses. And then on the inside of the parentheses, we'll go and we'll put x, because that's what remains, as I just showed you, minus, and we'll divide again, negative 6x over 3x, which is just going to be 2. Okay, we'll put our plus sign. And then we'll do the next part. What is negative 2x plus 4? Okay, well, negative 2x plus 4, what could be our greatest common factor between the negative 2x and the 4? Well, it would have to be 2, right? Because nothing else could go in past 2 into both of those terms. So we'll put the number 2, we'll put 2 right here. And then if I divided negative 2x over 2, it would just leave me with a negative x. So negative x. And if I divided 4 by 2, it would leave me with just positive 2. So now another way to write this out right here is to say negative 2 of x minus 2. And the reason I'm doing that is because we already have an x minus 2 here. So why not just make this equivalent to that so it's easier to use? So I'm making this equivalent. So now we have this right here, x minus 2, and we have a 3x of x minus 2, right? So how can I do this now? So basically, what we're going to do is we're going to, from here, we're on our last step, because what we're going to do is we're going to take the two things that are outside the parentheses and mush those together. So it's going to become 3x minus 2, because we're just taking this and we're taking this. And then we're going to take the x minus 2 and the x minus 2 right here, and we're going to merge that into one giant parentheses, right? It's going to be x minus 2. And then from there, that is our answer. So I know that was a lot of steps. So instead, I'm not going to, since that one really tied into factoring by grouping, I'm not going to do another example because it takes a while, but I will do some practice problems for you guys in a second. And once again, I just want to remind you guys, if you're asking yourself, how does this factoring make sense? It's because if I were to multiply anything, right? If I were to multiply the factors that we end up getting at the end, it would always lead me into the original function right here, right? So let's just do one more example. So if I were to do this example right here, 3x minus 2 times x minus 2, we are saying that those are the factors of 3x squared minus 8x plus 4. So if I were to FOIL that out, it'd become 3x squared minus 6x minus 2x plus 4, and that is equal to 3x squared minus 8x plus 4. So that is a great way to check your work. If you just multiply your factors and make sure it fits into the original function that you're given. So now I'm going to do some practice problems with you guys. Feel free to pause the video, come back in a second, and I will show you guys how to do it. All right, I hope you paused the video. Thank you so much for trying. Now let's see if you got them right. So we started off with a bit of a more simple one like I did at the beginning. Let's see how to do this one. So we have an x squared plus 3x minus 10. So to break this one down, what we're going to do is we're going to say again, what are the products of A and C, right? So the product of A, which is 1, and C is negative 10, right? So it's negative 10 right here. And then the sum would be 3, right? Because that is what B is. Okay, so now we have to think, okay, what two numbers could I use that could multiply to get me negative 10 and also add up to positive 3? So let's think. How about 5 and negative 2, right? Because if I multiplied positive 5 times negative 2, it would get me to negative 10, and it would also give, and positive 5 minus 2 would give me a sum of 3. So it works out, right? So let's write this down. This would be, we'll do 5 times negative 2 and 5 minus 2. Good. And that would work out. So now we would just write this as x plus 5 and x minus 2. And that is your answer. Let's try another example. This one right here. 12x cubed plus 2x squared minus 30x minus 5. So this one is where we do factoring by grouping. Why? Because they give us 4 terms, right? We have 12x cubed, 2x squared, negative 30x, and negative 5. So what that means is that we have 4 terms overall, and we're going to be breaking this down into 2 smaller parts to solve it, like I did in that previous example where we had the giant problem. So what we're going to do now is we're basically going to split this up into 2 halves, right? So this is the first half, and then this is the second half. So it becomes 12x cubed plus 2x squared, and then we'll add a plus sign, negative 30x minus 5. So now we need to figure out what factors would work out for each of the individual parentheses, right? So what is the greatest common factor from this right here? It would be 2x squared, right? Because I could divide both of them. I can divide both the 12x cubed and I can divide the 2x squared by 2x squared. But I can't divide anything further than that. So right, I'm gonna put 2x squared on the outside, and then on the inside, we're going to divide the 2x squared out of each of those terms, right? So 12x cubed divided by 2x squared would be 6x. And the 2x squared divided by 2x squared would be equal to 1. And then we'll add a plus sign, and we have to do this again, right? So what is the greatest common factor between the negative 30 and the negative 5? It would be negative 5, right? So it'd be negative 5 times, and then what we have to basically figure this out now. So negative 30 divided by negative 5 is equal to positive 6. So it would be positive 6 with an x. And negative 5 over negative 5 would be equal to positive 1. So do you notice something in common? We see a 6x plus 1 and a 6x plus 1. So we can just make that one thing. So 6x plus 1. And then on the outsides of both of the parentheses, we have a 2x squared and a negative 5. So that would mean that we're going to put those in their own parentheses, but we're going to mush them together. So it's going to become 2x squared minus 5. Good. And then that would be our answer, right? That's not too bad. We're going to do the next one now. So we have 3n squared minus 8n plus 4. So how do we do this one? This one is going to be very similar to this one we did right here. It's going to be very long. I'm going to try to break this down one more time. And then the last problem we're doing right here is also very similar. I'm going to go a bit faster on that, hoping you've started to learn a bit faster now. So we're going to start here. 3n squared minus 8n plus 4. So our product would have to be of what? A times c, so we have 3 and we have 4. So it becomes 3 times 4, which is equal to 12. And then we have a sum, which would be of b, which is negative 8. Right here. Good. So what two things multiply to 12 and add to negative 8? It would be, how about negative 6 and negative 2? because -6 and -2 would multiply to +12, and -6 and -2 would add to -8, right? It works out. And again, we're seeing some parallels already. Oh wait, this is the same problem. This is the same problem we just did. Okay, so I'm going to skip this one. My bad. I did not mean to put this in twice. I was wondering why this seems familiar. Okay, let's go to this one. 5n squared plus 19n plus 12. So to break this one down, we're going to do the same thing I was just doing with that last one by accident, by putting it in twice. Okay, so the product would have to be of a times c, right? So we have 5 and 12. Let me zoom out a bit. This is hard to write. Okay, so the product, here it is. Product would be 5 times 12, which is equal to 60. And the sum would be 19. Right? Do you see a pattern here? So what we're going to do now is we're going to figure out, okay, what two things multiply to 60, and do those two things also add up to 19? So if I'm thinking around for a bit, right, I have some time on my hands, I'm thinking around, I would think eventually, oh, what about 15 and 4? Because 15 and 4 work perfectly. 15 and 4 both add up to 19, and they both multiply to 60. So 15 times 4, and 15 plus 4. Right? Works out perfectly. So now what I'm going to do is I'm going to think about this. I'm going to break the 19n into 15n and 4n. And now we're going to do our factoring by grouping, right? Because now we've formed like 4 terms in total, right? We have 5n squared plus 15n plus 4n plus 12. Okay, so now let's split this up into 2 halves. So we have this and we have this, as you can see. So now we have to think, okay, what is the greatest common factor between 5n squared and 15n? Well, the answer would have to be 5n, right? Because nothing else could be divided into 5n squared and 15n that would go any further. So we'll go and put 5n on the outside of the parentheses, and on the inside of the parentheses, we have to put whatever 5n squared divided by 5n is, which is just n. And then now we have to do 15n divided by 5n, which is 3. And then now for this parentheses, we have to also think, okay, so what are the common factors between 4n and 12? So we have to think, okay, and I would think eventually, how about 4, right? Because nothing else could go in past 4. So it'd be 4 on the outside of the parentheses times n, because 4n divided by 4 is just n. And then 12 divided by 4 would be 3. So n plus 3. And we see we have a common thing right here. So that means we could go further. So now we're going to go and do 5n plus 4, because those two things are on the outsides of both parentheses. And on the inside of since we have 2 parentheses whose insides are the same, we'll just make those into one giant thing, which would just be n plus 3. And there is our answer. Okay, so if you struggle at any point, which I know I did when I first learned this, feel free to rewind the video, try out some practice problems. I always recommend places like Kuta Software. They have a lot of stuff. I get some of these problems I use in the videos always come from Kuta Software, so I would always recommend using them because they're very, very good. You can challenge yourself, and then I would also recommend your textbook if you want more factoring practice as well. And then there's also Khan Academy, which has a lot of practice problems for free. So if you can use these 3 things, and when you're studying for your next test on this, it should be very helpful. All right, thank you so much for watching. Come back next time.